In the first part of the lecture, we'll have a look at two different representations of a straight line using the equations y equals mx plus c and ax plus by plus c is equal to 0. Of the two representations, y equals mx plus c is probably the easiest to use and the most convenient in terms of the information that it gives us about the appearance of the graph. The value of m corresponds to the gradient or the slope of the line, and the coefficient or the constant term c tells us the y-intercept. So that's the place where it cuts through the y-axis. In this case it's going to be here. So if we know m and c, we can immediately get some visualization of what this line is going to look like as a graph. However, in the other representation, ax plus by plus c is equal to 0, that visualization process is not so easy. However, this form is useful when we want to solve simultaneous equations. Alright, let's have a look at a couple of examples. In both of these examples, we'll use the form y equals mx plus c. In the first one, we want to find the equation of the line with slope 2 passing through the point 5, 1. So we'll start by writing down y is equal to 2x plus c. And of course the reason we know that this is 2 is because we're told that here the slope or the gradient is 2. Next we have to find the value of the constant c. And we can just substitute the values of the coordinates at P to do this. So we have y, which is 1, will equal 2 times 5 plus c. So therefore c is equal to minus 9. Finally then we can write down our equation y is equal to 2x minus 9. In the next example, we're given 2 points, and we want to find the equation of the line passing through these points. What we can do is we can take point P first, and writing this in the form y is equal to mx plus c, we can write 2 is equal to m times 1, which is the x value, plus c. And we'll call that equation 1. And similarly at Q, we can write 6 is equal to m times 3 plus c. And we'll call that equation 2. We want to find the values of m and c, so we're going to solve equations 1 and 2 simultaneously. 2 minus 1, we're going to get 6 minus 2 is 4, that will equal 2m plus 0. So that's going to imply then that m is equal to 2. Knowing the value of m, it's now very easy to find c, and you should find that c is equal to 0. So we can write this equation as y equals 2x. Well, that's quite a coincidence. That's our favourite function from the previous lecture. It keeps cropping up, doesn't it? Alright, let's have a look at how we can use the other form of the equation, ax plus by plus c is equal to 0. In the first example, we're going to convert an equation that's given in the form y equals mx plus c to the form ax plus by plus c is equal to 0. So we have y is equal to 3x plus 4/5. Well, what would make life a little bit easier to start with would be to multiply this whole equation by 5. So we'll get 5y is equal to 15x plus 4. So all we have to do now then is just rearrange it. So we'll take the terms on the right hand side over onto the left hand side, and we get 5y minus 15x minus 4 is equal to 0. That's our answer. In the second example, we're going to do the reverse process. We'll go from an equation that's written in the form 4x minus 3y plus 2 is equal to 0 to one that's in the form y equals mx plus c. So we can write minus 3y is equal to minus 2 minus 4x, and if we divide everything through by minus 3, we'll get y is equal to 4/3 x plus 2/3. Okay, now have a go at the multiple choice question.